let's take some time to talk about mirrors and how they work and how reflections work in detail. So this is the more technical definition as opposed to the model that roughly outlines things. So first we're going to talk about the law of reflection. Light on a mirror obeys the law of reflection, which says that the angle of incidence is the same as the angle of reflection. And what I want to point out here, just like with refraction, angle relative to normal line. So if you look down at the diagram down here, you see that the angle coming in is equal to the angle going out relative to that normal perpendicular line. And so this explains why images or objects appear on the other side of a mirror, because we assume, or our sensors or our brains or whatever's measuring that light kind of assumes, quote unquote, that light traveled in a straight line. So if you look here, some of the light that went slightly up and slightly down, it ends up bouncing off the mirror, hitting our eye at the top, and you can kind of trace these, and basically if we assume that these came in at the same, in straight lines, they had to have started on the opposite sides here. So our brain doesn't and sensors don't do anything to be like, oh, this is clearly a mirror, so therefore I'm not going to pretend like I see something on the other side. Our brain just says, oh, something must have come from the other side. It's a weird thing to wrap your head around, so if you're confused, talk with me in class, but that's kind of the rough idea that we've got behind here. Now, what happens with curved mirrors? A curved mirror is going to reflect light based on a focal point. So if it is a concave mirror, so that means the mirror is curved inwards towards a light source. So if you could kind of, if the top and bottom are coming towards you or towards the light source, this reflects light to the focal point on the same side. And if it's convex or curved away from the light source, it reflects light as if it came from the focal point on the opposite side. And technically that's each of these only have one focal point, but I'm pointing out which side the focal point is on. So the focal point is always inside the curve, and the light will always bounce as if it was passing through that focal point. That's what the definition of the focal point is. So in the first example here, we have concave, so all the light's going in at straight lines, but it's bouncing inwards through that focal point. In the second example, we have all the light coming in straight lines, and then it bounces as if it had come from the focal point. So you see those dashed lines kind of pointing the direction that it goes. So what this ends up doing is the objects inside these mirrors end up being shrunk or expanded, and you end up being able to see more or less than you would in a traditional mirror. So in general, the application of a concave mirror is either to magnify things or to heat something up, because you can focus all the light into a single place. You can use concave mirrors to heat up water or create an oven. In general, convex mirrors are used to show you more than you would be able to see otherwise out of a mirror. So if you've ever gone to a corner and then up in a corner in a building, so where a hallway turns, and then up kind of at the ceiling, there's a mirror that's curved convexly or in a convex fashion. That's so you can see more of the hallway than you would if it was just a flat mirror. So that's what we have with mirrors. If you have any questions, let me know.